Okay, so I just took a picture and I had 3 bars of power. Now I've got 1 bar of power for a video, so that shows how much power a camera uses. So we're back to the well videos today. This is research, and I'm going to be making formulas out of the keywords in the data, okay? So there's Markov chain, Higgs signal, X Boson Stratonovich, Atlas time series, Stochastic. So this is actually, sorry, I'm not in the well, I'm in the Higgs right now. I'm bouncing back and forth between the two. So this is a graph that says E is 03, 07, 04, 06, E and A, okay? So August 20, 2012, formula ID. So this is a Markov chain, and this is a continuation of the previous video. So the formula ID is Higgs boson plus Markov chain plus 5 forces, axial included, new boson particles from the Higgs signal. Quote from Wiki: a Markov chain named after Andrei Markov is a mathematical system that undergoes transitions from one state to another between a finite or countable number of possible states. It is a random process usually characterized as memoryless. The next state depends only on the current state and not on the sequence of events that preceded it. This specific kind of memorylessness is called the Markov property. Markov chains have many applications as statistical models of real-world processes. So August 20th was when I was working on this research, and today is September the 13th, 2012. My thoughts: Atlas. I see the 0.6 and 0.4, which is in this here. See the 0.6, 0.4 with the A. And the number 6.4 came up when we looked at the second set of data on your CERN Higgs Boson Particle data. So I'm referring to the Atlas graphs, okay? A and E stand out. 0.7 would be the W7 X Stellarator with Tevatron plus plasma confinement density control plus reduced collisionality plus NSTX. Cross-referencing with line 18A3Z3D NSTX. Reduced collisionality, plasma confinement, density control W7 X, 5G well SETI comes with confined plasma, vessel wall, antenna, scrape off plasma, and there's a core plasma. That's what it looks like. My thoughts continued. The Higgs boson went from one state, a signal, to another, the creation of 2 photons. Look at the Markov chain plus the Markov property plus statistical model, new standard model with the 5 new forces we're looking for based on the Higgs boson particle mass bosons. Quote from Wiki: in probability and statistics, memoryless is a property of certain probability distributions, the exponential distributions of non-negative real numbers, and the geometric distributions of non-negative integers. The property is most easily explained in terms of waiting times. Suppose that a random variable, x, is defined to be the time elapsed in a shop from 9 a.m. on a certain day until the arrival of the first customer. Thus, x is the time a server waits for the first customer. Quote from Wiki: the term memoryless and memorylessness have sometimes been used in a slightly different way to refer to Markov processes, in which the underlying assumption of the Markov property implies that the properties of random variables related to the future depend only on relevant information about the current time, not on information from further in the past. My thoughts continued. The key words in this data is the X. A new formula idea from data about memorylessness. The X boson particle from Higgs boson signal, a boson mass Higgs particle, plus non-negative integers, this came up in the new data recently, plus distributions, plus waiting time, plus X, plus time elapsed, plus X, server waits for customer or Higgs signal, plus time equals same time, plus Markov processes, plus Markov property, plus random variables, plus future, plus current time, plus not past. My thoughts continued. Keywords from the data brought up this interesting graph that looks like a Higgs boson signal. Quote from Wiki: in a stochastic or random process, there is some indeterminacy. Even if the initial condition or starting point is known, there are several, often infinitely many directions in which the process may evolve. So there's the graph there I was looking at that reminds me of the Higgs signal. Time series random data plus trend with best fit line and different smoothings. My thoughts continue. Keyword here is time series. Quote Wiki: in statistics, signal processing econometrics, and mathematical finance. A time series is a sequence of data points, measured typically at successive time instants spaced at uniform time intervals. 20th of August 2012. This is what you're looking for, the Higgs boson signal line. Formula idea. Random variables plus non-integers. These two need to be put into the data that you are comparing with ATLAS, CMS, and CERN. Quotes Wiki. Stochastic calculus is a branch of mathematics that operates on stochastic processes. It allows a consistent theory of integration to be defined for integrals of stochastic processes. With respect to stochastic processes, it is used to model systems that behave randomly. The best known stochastic process to which stochastic calculus is applied is the Wiener process, named in honor of Norbert Wiener, which is used for modeling Brownian motion as described by Louis Béchil in 1900 and by Albert Einstein in 1905, and other physical diffusion processes in space of particles subject to random forces. Since the 1970s, the Wiener process has been widely applied in financial mathematics and economics to model the evolution in time of stock prices and bond interest rates. The main flavors of stochastic calculus are the Ito calculus and its variable relative, the Malavian calculus. For technical reasons, the Ito integral is the most useful for general classes of processes, but the related Stochastic integral is frequently useful in problem formulation, particularly in engineering disciplines. The Stochastic integral can rarely be expressed in terms of the Ito integral. The main benefit of the Stochastic integral is that it obeys the usual chain rule and does therefore not require Ito's lemma. So just remember, chain rule is a keyword, the word chain. This enables problems to be expressed in coordinate system invariant form, which is invaluable when developing stochastic calculus on manifolds other than Rn. The dominated convergence theorem does not hold for the Stochastic integral and consequently is very difficult to prove results without re-expressing the integrals in Ito form. My thoughts continued. Keywords related to the Higgs boson. Formula idea: Norbert Wiener plus Brownian motion plus integrals, stochastic processes plus physical diffusion processes plus space plus particles plus subject to random forces. My thoughts continued. Look at the time series or space between the Higgs boson signal and the two photons. There should be more particles in that area. That's what this seems to mean. This is continued in the next 3 segments, which means the next 3 videos, okay? Thank you for watching.